So with this, no intro today. With this chapter, simulation, it is very short. It will only be the lesson today. And it's only one concept that shows up a lot on free responses. This is just a specific type of what you see on free responses, but essentially we are learning how to take a sample or gather a sample or assign people to treatments. And then this chapter itself is actually carrying out the simulation. So on a free response, you could either be asked to set up the experiment or set up the simulation, or you could be asked to carry out the simulation. There has only been one free response in the history of AP that has ever had a simulation problem. However, the way that we, like we talked about in the last chapter, I said we were going to learn how to write or to set up an experiment, learn how to set up taking a sample. These go hand in hand. So the only difference in actually carrying out the simulation is going through the trials and going through a random number generator. But we're going to learn how to design or how to set up an experiment and assign people to treatments and things like that. So the word simulation is the imitation of chance behavior based on a model that accurately reflects the experiment under consideration. So essentially a simulation is just carrying out the experiment using random numbers, because that is how we can test an experiment without actually carrying it out ourselves. So there are several steps, and it will end up being about 4 or 5 sentences long when you design these. And there are steps in a checklist that you have to go through, or things that you have to think about. So you have to state the model, state what one trial looks like, state what you would record, and then, so this is the part that you would have done for a free response for the last chapter. And then these two components are actually carrying out the simulation. So you could be asked one of two ways. You could either set it up, or you could set it up and then carry it out. So a simulation is actually carrying it out. So if we look at the example below, we have a dartboard, and it says some stat students are designing a game for the school carnival. At the carnival, a player will throw 3 darts at a target with 3 concentric circles. The 3 regions are labeled with the number of points that a player will earn for hitting in that region. If a dart misses the target, the player can throw it again. So here we have our dart board. In the middle, you get 10 points. Middle circle is 5 points. Outside circle is 1 point. It also gives you the percentage of the total area. So for instance, if you have a 6% chance of hitting the 10 or getting 10 points, you have a 33% chance of getting 5 points and 61% chance of getting 1 point. So the students want to determine what the winning score should be so that approximately 40% of the players win the game. So a player would win if they received at least the winning score. And so if 40% of the players win the game, then that means that 60% lose the game. So what I'm essentially trying to figure out is I want to find the value at the 60th percentile. And if I find the value at the 60th percentile, let's see, like possible scores are from 0 to 30, right? Because if you hit the 10 3 times, you get 30. I want to figure out what is the score, what is the value, so that 40% win and 60% lose. So what is this X value? What is this value to tell me that 60% lose, 40% win? So I need the 60th percentile. So we're going to design a simulation that involves probability and involves chance that tells me what score I need to make. And in order to do that, we're going to actually have to carry out some trials and carry out... Yes, ma'am. And so we can actually determine that score, but something that is important, that it is only a valid score. It only has validity if you have 100 trials. We will never ourselves carry out 100 trials. An AP test would only make you do 3 or something like that. So we will never ourselves carry out 100 trials, but in order, like if you see this on a multiple choice question or something and you see a simulation, it's important to know that it's only valid if you have 100 trials. And so then we're going to create it. So we're going to flip the page and actually write out the steps for the simulation. Then we will come back and we will create a dot plot and we will determine what our score needs to be. So go ahead and flip the page. Okay, so here's the checklist. You will see 5 steps. There's a foolproof plan that is going to help you get 100% on a free response of setting up a simulation. And so, what's the plan? Where are they coming from? What numbers are you choosing from? What or who do the numbers represent? And are there numbers that you need to omit? So these are all things that you need to think about as you're answering this first question. It is all about the numbers. So, if we look back at our chart on the last page, I am looking at the percentage column. There are 100, so it's 100%. And so I'm going to need to choose from 100 numbers. And so numbers will always come from, usually the easiest one is a hat because it's easier to write. Calculator could be a random digit table. You can use either one of those. And then table, random digit table. I'm going to say when you're answering these on an AP test, always use the hat method because it's easy and it always works if you can explain it clearly. The only difficult thing about this is that there is no, like I try to fit this into a script as much as possible, but there is so much independent thinking when it comes to these questions that there is no way to put it into this little box. I try as hard as I can to put it into a box, but you really are free to write however you want as long as you hit these targets and you fit the mold of what they're looking for. So we're going to use a hat. What numbers am I choosing from? I'm going to choose numbers from 1 to 100, but instead of using 3-digit numbers, 100 would represent 00, and then 01 through 99. And those represent the percentages, and you'll see why here in a minute. Because that's like saying it's 100. So you can fit 100 numbers into 2 digits. Your goal is to use the least amount of digits as possible. So if you only have 10 digits, you can use 0 through 9. But if you have 11 numbers, then you have to jump up to 2-digit numbers. Then if you have like 105 things to choose from, then you have to use 3-digit numbers. So your goal is to use the least amount of digits. But if you use 2-digit numbers, like if you have exactly 100 numbers, so we have exactly 100%, then using 2 digits is possible if we use 00, and 00 would represent 1 through, or would represent 100. And so what do my numbers represent? So let's say that I end up getting 1. That represents like how many points I'm going to get from the target. So how many points? If I'm only using 2-digit numbers, will I be using all of them, or are there any that I need to omit? If I'm only looking at 2 digits at a time, will every single number represent something if they're corresponding to the percentages? Yes, so there are no numbers that I need to omit, none. So here's my answers to my problems. Now we're going to create a nice little sentence, or 2 sentences that can represent that. So I will use numbers 00 through 99. Since we're actually executing it, I'm going to say for this example that we're going to use a random digit table. So from a random digit table. So I'm using these digits to represent the number of points earned from throwing darts. So we got to add some context in there. Now I need to assign my numbers. So I'm using digits 00 through 99, but how do I know like what numbers represent what? So if we go back to that chart and it tells me the percentages for 10 points, 5 points, 1 point, what numbers could I use to represent getting 10 points? 00 through 05, right? Or you could do 1 through 6 because you need 6 numbers total. It does not matter what 6 numbers that you use, but my suggestion would be to do 00 through 05.
So why can't you include the 6?
Because that would be 7 numbers. Because you have 0, 1, 2, 3, 4, 5, 6. So you only need, yes.
So you're counting the percentage that corresponds.
So I need 6 numbers to represent 10 points. I need 33 numbers to represent 5 points. And I need 61 numbers to represent 1 point. And that means that there's a 6% chance of getting 10 points still. Does that make sense? So, here I'm going to assign the numbers. So 0 through 05 represent earning 10 points. So then the next 33 would be 06 through what?
42.
No, this is so hard.
37.
38. 38.
Oh.
58.
Oh, you just add them and subtract 1.
Yeah.
You just subtract 1 from everything. It's okay.
Represent 5 points. And the next one is easy. 39 through 99 represent 1 point. So, if I were to break this sentence down into 2 parts, the first part is telling me what numbers they are and what they represent. So, I'm using this number and they represent this. That's like part 1. Tell me what numbers you're using and what they represent. So when I pull 1 from a hat or something, what does that tell me? It tells me that I'm earning 10 points. Then the second part of that sentence are assigning the numbers. So second part is assigning the numbers, telling me what numbers correspond with what. The second thing is, can I repeat numbers? So you just write a sentence saying numbers can or cannot be repeated. And it changes depending on whatever. Like if I'm choosing people to do something, then obviously you can't choose someone twice. But in this case, if I'm throwing darts, can I repeat numbers? Yes or no?
Yes.
You can score the same.
Right. It's not like I'm choosing people or anything.
Wait,
So.
so-
You're repeating like 0, 1, 0, 1.
You're repeating the point.
So if I were looking at a random digit table and it said 0, 1, 0, 1, like 1 would be chosen twice, is that okay?
Yeah,
Yes.
because it's still 6%.
Right.
Is that what you're saying?
Exactly. So numbers can be repeated. The third step is now saying, what will one trial look like? So when I'm looking at this random digit table, one trial means I'm choosing how many numbers?
100.
No.
For 1 point.
Like if so each person gets 3 throws.
7.
So one trial
Just keep saying 3.
is to select 3 2-digit random numbers from the table.
Select 3, 2, 2.
3 2-digit numbers from the table. Then the last sentence, is saying like once I do one trial, what am I going to do with those numbers? So you have to tell me what you're going to record. I'm going to record the total number of points earned. Okay, so let's say that I get 1, 5, and 7. Well, 1 and 5 would represent getting 10 points, and 7 would represent 5 points. So I scored 25 points. So once you execute one trial, you write a sentence about what you're going to record. What am I counting? Kind of like my response variable. I'm looking to see how many points I've earned. So I will record the total number of points earned. And then I am done.
The randomization guy.
So then what sets this apart from like being just setting up an experiment versus actually doing the simulation is now they provide me with the random digit table and I have to execute it. So, yes, Reese.
Why would you record the total number instead of?
So like with each trial is a person throwing 3 darts. So I want to know how many points you earned when you threw 3 darts. So I'm recording the number of points.
I think we should figure out that 40%.
So once we do that, then we're going to figure that out. Yeah.
Oh, okay. So is that on that one? We should always record.
I'm going to record the number of points earned because that's what I'm trying to figure out.
Okay.
So it wants me to do, it'll tell you how many trials they want you to do. Let's do 4 trials, but if it were an AP test, it would tell you. But I'm going to say let's do 4.
That's like
With
12.
2-digit numbers.
Do what? Yeah, I'll look at 12 numbers, right. Okay, so trial 1,
32.
trial 1, I have 32, 13, 37. So 32 is how many points? 5. 13 is 5.
5.
Okay, that was trial 1. Trial 2, 18, 32, 97. So that should be 5, 5, and 1. It's 11 points. Trial 3,
Oh,
84, 16, 27. I think you get 1, 5, and 5. And that should be 11 points. And then for 4, 81, 68, and 4.
I'm go. Can I use a calculator?
You get 1, 1, and 10. So that's 12 points. So that would be the only thing that an AP test would ask you to do would be carry out 4 trials. Now let me talk about something that is important that you'll see on your homework. You either choose a set number of numbers, like in this case we chose 3, or there is this thing called a stopping rule. And the stopping rule is this little bullet right here. How do you know that you are done? You could keep going until you stop at something. So an example would be, I've seen, I think on the homework, there's one where it says, like Johnny wants to get 1 prize from every type of cereal box. So he wants to get 1 of every prize. And so he's going to keep buying cereal boxes until he gets until he gets 1 of every prize. So in your recording sentence, you would say, I'm going to keep choosing random digits until I get 1 of every prize. Another example would be, I want to roll a dice, and I want to see how many rolls it takes me to roll a 1, 2, 3, 4, 5, and 6. So this sentence right here for step number 4 would be, I'm going to keep choosing random digits until I have rolled 1, 2, 3, 4, 5, 6, and then I stop. So there's 2 different types of scenarios. You either have like a set number where I'm choosing 3 and I stop. I'm choosing 3 and then I stop. So that's one option. Or you keep going until you have the result. So keep going until result that you want. So until desired result. And that's considered like a stopping rule. So there's 2 different options. You either have a set number or you keep going until you stop.